Okay, let's start the homework packet. Just to be making sure this is working. Okay, cool. So, homework chapter 14, acids and bases. Do not do 14.1c, 14.4, 14.5. So we're kind of missing a lot of parts. I might add a second homework packet if we finish this one on time. Also, there's a quick textbook there, chapter 15 in the textbook. And let's go from here. So first thing I'm going to do is open this up in Notability. All right, here we go. So just starting off, we have some study goals here. Definitely want to keep those in mind for your studying. It's great to know these things. I'm going to test you on them, just not exactly these things. They'll be about the goals. Fill in the think about it terms. We'll definitely talk about a few in class. And as usual, the key terms are great. Now there's a way you can do this correctly, and there's a way you can do it incorrectly. If you just fill in the letters, I won't know the difference. The responsibility is for you to learn a little bit about it and then go from there. All right, so to read all this stuff, and what do we need to know? Well, acids have hydrogen, bases have hydrogen hydroxide ions. That's really important. Bronsted-Lowry acids and bases, well, we're talking about protons still, and we're going to get rid of them. If you're an acid, if you're a base, you're going to take it in. Don't need to worry about the organic stuff. We'll talk about that at a later date. Okay. Here we go. 14.1a. Indicate if each of the following describes an acid or a base. Now, if it turns blue, litmus, red. Well, really easy way to check that out is we go back to our slides. And here we go. Turns blue, litmus, pink. And so, looking on our slides, looking at our slides, if it turns the blue litmus pink or red, we know it's an acid, and that's great. Whatever. Cool. So, turns it red. Acid. Double check it. Great. It tastes sour. Well, let's go back. Well, that's also an acid. So use your notes. These are straight from the notes. Fill in the blanks with the name and the formula. So if we go back there, we talk a little bit about names. If it has an H, for HCl, H is what we're going to pronounce as hydro. The base word, not like the acid base, for chlorine is chlor. And then the ending, the suffix, it's going to be an ic. And then, of course, acid. So hydrochloric acid. If this base, chlorine, was something different, say, I don't know, HBr, hydrobromic acid. So we'll probably drop that O and just make, because you don't want to have two vowels back to back, weird English, hydrobromic acid. So that's how we name these ones. So that's how we get there. Now, when it comes to bases, we pretty much name it pretty much how anionic bonds are named. Na for sodium, OH for hydroxide, sodium hydroxide. Sweet. Fill those out, do your best. If you do have issues with that, double back to what we did last semester. we talked about naming at that point, and you can go from there. Don't need to do this one. Bronsted Lowry. Now this is slightly different than just saying it has an H or an OH. This is telling us if a proton is donated to something else, it's an acid. So that's important. And what we started choreographing here is the relationship between an acid and its conjugate base. So if we look at this example here, HCl, it donates a proton, and whatever it's left with over here, this is what we call the conjugate base. Conjugate as in it's like, kind of like its breakup, friends with benefits left over, something along those lines. And if we go with H2O, well, it gained it. This will be its conjugate acid. So that's how we're going to rearrange this. Our base, in this our scenario, which would be our lesser, weaker acid, so to speak, with the terms that we have now, will gain a hydrogen, making it a conjugate acid. So our water here gained a hydrogen, and our HCl here lost a hydrogen. All right, so complete the following conjugate acid base pair. If H2O is a conjugate acid, the conjugate base would be the loss of that proton, leaving us with just OH. Cool. If HSO4 minus, if we lose a proton, we're still going to have that electron, so we're going to have an we're going to lose this hydrogen. It's going to be donated, but we're going to keep the negative electron. So instead of 1, we're going to have a -2. So we'll have SO4 2 minus, or -2. Now, let's see here. What about this one down here? Fluorine. Excellent. So this is the conjugate base. The conjugate acid would be with the hydrogen connected to it, or just the proton. We were left with HF. So as you see here, what we're doing here is we're adding and removing can't spell. So that's really important. We need to add or remove protons. That's pretty much all we're doing when we're talking about acids and bases. Where's the movement of the proton? Remember, these are solutions, specifically in water as the solvent and hydrogen as the solute. Cool. So I'll leave that to the rest of you for finish up that one. Let's see here. 4.2. All right, so identify the conjugate acid-base pairs for each of the following reactions. Well, we're looking at the transfer of the electrons. So what base pairs do we have? Well, this one is linked with this one, and this one is linked with this one. This is my starting off with my acid. Oh, let me back that up. Initially, my acid has a conjugate base. And the base transforms into a conjugate acid. Cool. Remember, transfer of electrons, transfer of a proton. That's all we're talking about. All right, cool. And here we go. I'll leave this one up for you. With that basic knowledge and what we talked about in class, you can finish this up. Let's see. Strength. Cool. Remember, when we talk about strengths of an acid and bases, we're talking about the amount of dissociation. How much do they break apart? That's what's important. Okay. Yeah, this stuff seems pretty straightforward. I'm going to leave this up to you guys in your capable hands. I think you are going to do a great job. So keep up the good work. Let me know if you have any questions. I do have a quick joke, as somebody asked to put jokes on there. I know it's terrible, but I can't count how many times I failed math at school. Ever since I took geometry in school, my life has turned around 360 degrees. These are so terrible. My room plus the internet connection plus music plus food minus homework equals perfect day. That's probably the best one. Cool. Anyways, have a great night. We'll see you in class.